So in this video we are going to understand the unique path second, right? So we have already seen the I think in the first part of this playlist, the unique path, right? So this is the third video of this you can say playlist, right? The 63 unique path second. So what we have to find here, let's understand from the question. So you are given a matrix m cross n integer in the grid, right? That is an array. So there is a robot initially located at the top left corner, as you can see here in the example, that is at 0 0 position in the grid. So the bottom line is how we are going to traverse from here to here at the bottom, right? Top left corner to bottom right corner. How we are going to do that, that we are going to understand. So first we have to understand the initial position what we have. So initial position at 0 0, that is the top left corner, and we have to reach what at the bottom right corner, that is you can say m minus n and m minus 1 and n minus 1, that is the last row, last column, and that is called the grid m minus 1 and this one. Okay, so the robot can either move downward or rightward at any point of time. So there is an obstacle, right, and a space are marked as 1 or 0 respectively in the grid, right? So obstacle as 1 and a space as a 0 means if obstacle is coming, so he cannot move, right? So a path that robot take cannot include any space, that is an obstacle, right? We have to return the possible unique paths that the robot can take to reach the bottom right corner. The test case is generated similarly to the 9 this case, so we can see later, don't worry. So obstacle grid we have given like this, right? 0 0 0, and there is 1 here as you can see, and the rest of the are 0 0 0. Okay, so he cannot travel through the obstacle, right? Because a path that robot takes cannot include any square, that is an obstacle. This square he cannot take, right? So how he's going to move, right? So there is one obstacle in the middle of the grid, as you can see here in the figure, right? So this is 3 cross 3 grid, right? So there are two ways to reach the bottom right corner. Either he can go from here to here, or either he can go from here to here, right? Means he can take right and then down, and either he can take down then right. Okay, so this is the second question of the unique path. You have already seen the first path of the unique, right? In which how we are going to calculate. For calculating the dp at let's suppose I and j, right? What we are going to do, we are taking grid at let's suppose I and j, the current value at the grid, plus we are calculating dp at I minus I plus 1, take I plus 1 and j, and we are taking what dp at I and j plus 1. Okay, and which one is minimum, right? We are calculating, and that we will store into the current value of the grid, and that will come as a grid here, right? So the similar questions we have in this unique path, but only things we have added as a obstacle. We cannot include the obstacle path, right? You can see the another question, another example, right? So here is obstacle, so he cannot take this path, right? So he can take only one path, so there is only one answer, right? Now coming back to here, right, you can see the figure and you can understand how he can go, right? He can start from here and he can move like this as he is moving, right? So at the last he will reach at this position. How he are going to starting from here, right? He can go like this. Okay, let's understand how we are going to find. So first of all we will calculate row and another will calculate column. Now at 0 0 is nothing but 1, right? If this obstacle grid contains 1 means we are not going to do anything, we will return our control there only. Okay, so it is saying that if obstacle is already at the first grid. Okay, so first of all let's suppose what we are trying to do here, let's suppose is obstacle is already here, right? So how he can move, right? He cannot move, so we will return from there only. So this should also be your case, right? Case like with starts with obstacle, obstacle, right? So we cannot move. Next we can mark 0 0 as 1 now, because we have already done, right? Now from I 1 to row, first row to the last row will move, right? How will move, that we are going to see. The first is I, right? I and 0, right? So 0 will remain same, right, here in this case, and I will get change, right? So for all the row we are coming from here to here. Okay, next time we will move to here to here, right? Two path is here, so I will go with the first for the downward, right? This is for the downward and this is for the rightward, right? That's why we are going for I0 to you can say row, and this is for the column, that is rightward. Okay, so that's why the 0 will remain same. And how we'll going to find? We'll check if I00 is at 0, means we can go, and it should obstacle should not we will take -1 0, right? And if equal to 1, we'll return 1, otherwise 0. If it is equal to 1, right, then we will return 1, otherwise return 0. Similarly, we'll do for the column, we'll pass the same value 0 and I-1 equal to this at this, right? Now for row and column we'll do, right? So we'll start from 1 to 1 for the row, and another for loop for column. We'll check if I and j equal to 0, then we will calculate obstacle I-1 and obstacle j-1, right? You can see, and we can find your value, as you know that. Now we'll take I, otherwise what we will do, we'll pass I and j is equal to 0. We are not going to do anything. Okay, and at the last we'll return r-1 and c-1, means we calculate from here last grade, last cell of the grid, right? And we will return the value. Got it? Let me recap one more time. So we are taking row and column. We'll take initial value. If it is equal to 1, we will return 0, right? If not, then we will mark 0 0 as 1. Then we will start from all the row, and we'll check if it is equal to 0. If it is equal to 0 and this I-1 and 0, right, is equal to 1, right? If this is the case, that we have already done, right? If this is the case, it means what? We will put 1, right? Otherwise 0. Okay, and this way sorry, in this way we will increase. So what we are trying to do here is we will start from here, right? So we will mark after moving, we will mark after moving, we will mark, right? We will mark this position as a 1. If obstacle will take, we are not doing anything. Okay, otherwise we will mark this line so that it will become like this. So he is starting from, as you can see here, right? He is starting from here some position, he is moving this. If that is not the case, he is marking as a 1, like this he will mark, and the last you can see here, he is starting from here, he will marking, he is marking, and he is calculating 2 path, 2 path, 2 path, 2 path, in the last he has 2 path. Okay, like this. So that's why either will pass 1 or 0. If obstacle at I means row, that row 0 if it is 0, and -1 0 if have 1, right? It means we have to pass 1. Okay, otherwise 0. Similarly for the column also, if it is equal to 0 or I-1 0 and I-1 will pass, then will become what? This one. You can mark this as a j also, so it will become a little easy for you. Now for the I and j will move, and we'll check if it is equal to 0, right? Because we have already marked all this one, right? So if it is equal to 0, we will find the value at this position and value at this position. If both are 1 1, then it will become 2 at this position, right? Otherwise we will mark it as 0 only. And finally we will return at here, and that's why we are coming initially, we have already marked everything, and then we are updating the value, right? 2 2 2 2, otherwise the rest of will remain 0. So finally at the last grade we will return this value. Okay, I think you understood. So complexity, we are going through all the row and column, but the space complexity is of 1. Okay, so thank you guys, thank you for watching this video. If you like this video, please watch the another part of this series, right, in which we will see the triangle question, right? And thank you for watching. Please subscribe, and please check out the whole videos in this playlist.